So let's take a look at section 6.1, which is looking at graphing. So we're moving into the graphing of the 6 trig functions. And so for the first lesson here, we're just going to start off looking at the basic sine and cosine curves. And you may have seen these at some point, maybe in a science class, if you ever think about looking at the graph of a wavelength or something where it repeats and it's cyclic. Cyclic meaning it repeats. So every so often it just has a repeating pattern. That's what your sine and cosine curves are going to do. So I'm going to start with the basic, just f of x equals sine x function. And let's look at what the graph of the sine function looks like. So if we think about the values on the unit circle, that's exactly where these points are going to come from. So our x values would be in radian measure, our y values would be the regular y values on the unit circle. So think about when x is 0, the sine function would also be 0. At pi over 2, sine of pi over 2, that would be at the top of the unit circle there, would be 1. Sine of pi on the left side of the x-axis on the unit circle, the sine value there would be 0. Sine of 3 pi over 2 would be -1. And then it starts back over at 2 pi with 0. And so it would just repeat and follow that pattern. This is called one cycle or one period of the sine function. So for the sine function, the basic cycle or the basic period goes from 0 to 2 pi. So, all right, so let's label this on the graph. So we've got pi over 2, and then pi. I'm try to space these out as evenly as I can. There's 3 pi over 2, and then 2 pi. All right, so 0, 0 would start out at the origin. That's our first point. Pi over 2, the y value is 1. Pi, the value goes back to 0. At 3 pi over 2, the y value is -1, so we're down here. And then at 2 pi, it goes back to 0. So your sine curve would look something like this. It would come up, it's nice and smooth and continuous. There's no breaks in the graph. And there we go. So it has intercepts at 0, pi, and 2 pi, which should make sense because that's where sine is equal to 0 on the unit circles. And then its highest value is 1, its lowest value is -1. And that's the range for the sine function, is from -1 to 1. And this is one cycle, but this would keep going forever following that same pattern in both directions. Okay, so it's a continuous function. There's no breaks in the graph. It's cyclic. It follows that same pattern, and it repeats that cycle every 2 pi radians. Let's look at the cosine curve. So how does the cosine curve look different? Well, the difference is where it starts because of the values on the unit circle. So cosine of 0, of course, is 1. Cosine of pi over 2 would be 0. Cosine of pi would be -1. Cosine of 3 pi over 2 is 0, and then cosine of 2 pi is back to 1. So one cycle of the cosine curve is also 2 pi radians, so from 0 to 2 pi. So I'm going to label it very similar. So we're going to have pi over 2, pi, 3 pi over 2, and then 2 pi. All right, so then at 0, we start out up here at 1. So that's a key distinction between the sine and the cosine curve. The sine curve starts out at the origin, whereas the cosine curve starts out up here at 1. Pi over 2, we're down here at 0. Pi, we're down here at -1. 3 pi over 2, we're back to 0. And then 2 pi, we're back to 1. Okay, so your cosine curve is going to look like this. It's going to have a little hook on the end. It's going to come down, nice and smooth, continuous, no breaks in the graph. And there you go. So that's one cycle from 0 to 2 pi. And again, this would repeat indefinitely. The domain for this would be all real numbers, and the range would be from -1 to 1. And just keep going like that. Let's jot that down, actually, because the domain and range are kind of important. So for the basic sine curve, your domain is all real numbers, -infinity to infinity, and your range goes from -1 to 1. It stays in that little interval. Cosine is the exact same thing. Your domain would be from -infinity to infinity, and then your range would also be from -1 to 1. Doesn't ever go outside that box. Now the domain will never change. The range can fluctuate depending on if the graph has any shifting, and we'll talk about shifting in just a second. But here's the basic sine and cosine graphs. In general, the graphs are modified like this. So the basic equations will look something like this. A sine of bx minus c plus d. And so each of these variables, a, b, c, and d, will affect the graph in some way. So A represents the amplitude. And so you can think of the amplitude as how high and low the graph goes. In the basic curves, our amplitude is 1, right? There's a 1 in front of that cosine. There's a 1 in front of the sine. So the amplitude is 1. It goes up to 1 here and down to -1 here. Really, this is a very informal definition, how high the graph, how high or low the graph is. It's the height from the axis of symmetry. So if the axis of symmetry, for example, is the x-axis, if that cuts the graph in half, the height above and below that x-axis, that's your amplitude. All right, B determines the period. So the basic period for the sine and cosine curve is 2 pi. Every 2 pi radians, we're going to repeat that cycle, just like on the basic unit circle. But if you have a B value that's anything other than 1, that period can get changed. That either gets compressed or lengthened depending on what that B value is. So let's see. So the period we can define as the length of each cycle. So in other words, how far it goes before it repeats. Now, how do we compute the period? This is important. So the period is computed by 2 pi over whatever B is. So this is an important little formula we're going to use. So when you're asked to find the period, and then we're going to use that to sketch our graphs, always use the formula 2 pi over B. C determines the phase shift. So phase shift is a fancy word for horizontal shifting. Okay, so the horizontal shifting. So just like back earlier in the course when we talked about left and right horizontal shifting, we're calling it a phase shift now is the name we give it when we use these trig functions. And a little formula for finding the phase shift, I should have put this on here, but phase shift is always going to be C over B, whatever that is. So C over B. And another little reminder is that it's opposite, just like it was earlier in the course. So because of this minus sign in the formula, it's opposite whatever that is. So if it's minus C, it actually shifts it to the right. If it's plus C, it actually shifts it to the left. And the way we determine what that phase shift is and where we're going to start our graph is we're going to use the little formula C over B. And I'll give you an example in a minute. And then finally, D is the vertical shift, right? So that's just like it sounds, up or down. You're up or down shifting. Nothing special with the vertical shift. Remember, it's not opposite. It's just if it's plus 3, you shift the whole graph up 3 units. If it's minus 6, you shift the graph down 3 units. All right, so let's do some examples. Let's just start by identifying the amplitude and the period. So for this first example, the amplitude, and by the way, the amplitude is always by definition positive. Amplitude is a distance technically. So even if this A value is negative, we'll talk about how that affects the graph, but even if that A value, like here, you see this A value is negative, the amplitude itself is the quantity. So the amplitude is going to be 2 here. Similarly, the amplitude here would be 3, even though it's negative, the quantity is 3. So that's what we would say for the amplitude. Now, the period, let's talk about the period. So the formula we're going to use is this 2 pi over B formula. So in this case, it's going to be 2 pi over B. B is the coefficient on the x variable, so 2 pi over 1/4. Simplify that, multiply by the reciprocal 4 over 1. That gives me a period of 8 pi. So in this example, the period is lengthened. The graph is stretched out where it's going to repeat every 8 pi radians instead of just the usual 2 pi with the basic graph. So in this case, we have a longer period of 8 pi. Let's do this example. So the amplitude we said was 3. That's just the A value, the absolute value of whatever A is. Now the period then is going to be 2 pi over B. In this case, B is pi. So the period is just going to be 2. So every 2 units, this graph would repeat. So let's use this information to make a graph. And what I always generally ask you to do is 2 cycles. And we're going to use what's called the key values method. That's just the method I like to use. I feel like it's the most straightforward, where we make a table just like this and we plot what I call the key points. So the key points are basically the equivalent of what they would be in this table. The 5 key points, this is 1 cycle for the cosine curve. We want to get those same key points. What changes is where we would start the graph, and that's based on if there's any shifting, and the points we're going to use are based on whatever the period is. So assuming there is no phase shifting, the graph will start, the x value, I should say, will always start at 0 when you use this key values method. Now, there are negative x values, but when we graph it, I think it's easiest if you just start at 0 unless there's any phase shifting, and we'll talk about that later. Make sure you see what I mean. There's no phase shifting here. There's no parentheses. There's no c value, plus or minus the c value. We have an a value of 1/2. Let's jot that down. So we have it a is 1/2 and b is 1. That's all I have right now. So no phase shifting, so we're going to start the x value at 0. The next thing I would do is figure out what the period is. So the period is 2 pi over b. Of course, b is 1, so the period is just the basic 2 pi. And then what I do is I divide that into what I call quarter periods. And this is how I get those key values in that table. So the quarter periods, let me go ahead and write it down here. I'm going to call it QP for quarter periods. You're going to take the period of 2 pi, and you're going to multiply it by 1/4. So that gives me 2 pi over 4, and if you want to reduce that, you can make it pi over 2. So what that means is to get my key values, every pi over 2 units, I'm going to have another key value. So if I start out at 0, pi over 2 units later would put me at pi over 2. Pi over 2 units later, and if you don't want to worry about reducing, just add another pi over 2. That puts me at 2 pi over 2. Add another pi over 2 again, puts me at 3 pi over 2. Add another 2 pi over again, puts me at 4 pi over 2. And you can reduce these if you want to, but my advice is you just leave them while you're making your table. And then if you want to reduce them later, that's fine. But I would just leave them because I need to keep going. I wanted to get 2 cycles. So I'm going to keep going. 2 cycles is going to be 9 points altogether from end to end. So I'm going to keep going. Add another pi over 2 puts me at 5 pi over 2. Add another pi over 2 puts me at 6 pi over 2. Add another pi over 2 puts me at 7 pi over 2, and then finally 8 pi over 2. Now, if you stop and think about that, the period was 2 pi. I wanted you to graph 2 cycles. So 2 cycles would be 2 pi times 2, which is 4 pi, a distance of 4 pi total. So if I go from 0 to 8 pi over 2, guess what? That's 4 pi. So this is 2 complete cycles. You just remember 9 points. Let me see, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's what I thought. 9 points is going to get you 2 cycles when you're doing this quarter period method. You just stick to that every time. Now, to get the y values, this is where the amplitude comes in. If it's a sine function, sine starts out at 0, right? So sine of 0, of course, is 0. So sine is going to start out at 0 for the y value. Now, you're following the pattern you followed here. Remember, it went from 0, 1, 0, negative 1, 0, 1, 0, negative 1. You're going to follow that same pattern. The difference is because the amplitude is 1/2, I'm not going to go all the way to 1 for the first y value here. I'm going to go to 1/2. And then the next one would be 0, and then follow the pattern. So remember, it was 0, 1, 0, negative 1. So I'm going to go 0, 1/2, 0, negative 1/2, 0, 1/2, 0, negative 1/2, 0. Make sure it starts and ends at the exact same place. That's a complete cycle. But it's going to follow that pattern every single time. And that's why I like using these key points method, because it follows. As soon as you got that pattern down, you know what your amplitude is. You just stick to the pattern every time, and you'll get the hang of this. So let's go ahead and label everything. So I'm going to go ahead and label my points. We've got pi over 2, pi. I'm going to go ahead and reduce them now. 3 pi over 2. 2 pi, that's 1 cycle. And then we've got 5 pi over 2, and then 3 pi, and then I'm going to extend this a little bit. 7 pi over 2, and then 4 pi. And just to clean this up, I'm going to get rid of these quarter period notes here. All right, and then we'll put in our y values. So our highest y value, our maximum, is only 1/2 this time, and then my minimum is negative 1/2. So we start out at 0, and then 1/2, 0, negative 1/2, 0, 1/2. So it's going to follow that same pattern every single time. And again, make sure it starts and ends at the same location. Nice smooth curve, just connect your points. So there's 1 cycle, and there's 2 cycles. Okay, so you can see it repeats every 2 pi radians. It's going to repeat, and that's what we said the period was 2 pi. So that's what should happen. Okay, let's try the next one. We're looking at the cosine curve They want us to graph from 0 to 2 pi. Let's go ahead and figure out the amplitude and the period before we get too involved. So the amplitude, well, the A value, let's just write that down. So the A value is -3. The B value is 2. So that means the period is going to be 2 pi over 2, right? 2 pi over B, which is just pi. So this is actually a shortened cycle where the regular cosine curve, the cycle is 2 pi. This time the cycle is just going to be pi radians. So it's a little bit condensed. They want us to go from 0 to 2 pi, which is going to be 2 complete cycles, and that should make sense because if the period is pi, 2 cycles would be 2 pi, right? A distance from 0 to 2 pi. This graph has no phase shifting because there's no C value. Big clue is there's no parentheses. So if you have no parentheses, you have no phase shift. So let me go ahead and get all the x values down first. Let's do the quarter period thing again we talked about. So the quarter period means we're going to take the period, we're going to multiply it by 1/4. So the quarter period is pi over 4. So every pi over 4 radians, there's going to be another key value. There's no phase shifting, so my x value starts out at 0. So then my next key value is going to occur pi over 4 units later because that's the quarter period. So 0 plus pi over 4 puts me at pi over 4. Add pi over 4 again, the next one is 2 pi over 4. Add pi over 4 again, the next one is 3 pi over 4. Add pi over 4 again, that puts me at 4 pi over 4. So that would be one cycle. You see what I mean by don't reduce when you're making the table? I think it's easiest if you just leave them unsimplified. So that would be one cycle, 0 to pi, right? 4 pi over 4. Let's keep going. 5 pi over 4 would be the next quarter period, or the next key value. 6 pi over 4, 7 pi over 4, and then 8 pi over 4. So that is a distance from 0 to 2 pi if I reduce that. Now let's talk about the y values. So this time we're dealing with cosine. So remember that cosine starts out at 1. So the idea is that you're going to start out with cosine for your y value. You're going to start out at whatever the a value is. So in this case, the a value was -3. What that actually does is it reflects the graph. So instead of starting out like up here at 3, it's going to actually start out at -3. It's going to reflect it. And in the table, what we do is we just say, okay, cosine values start out at whatever the a value is. So this is going to be -3. And then it follows a pattern. So it's going to be -3, and then it's going to go back to 0. And then +3, back to 0, -3. This is why I like doing the key values, because you don't have to really think too much about how to get those numbers. You don't have to plug them in or anything. You just follow the pattern. If you know that cosine starts out at a, it's going to be a, so -3, 0, 3, 0, -3. That's one cycle. And then keep going. 0, 3, 0, and then -3. And notice that it starts and ends at -3. It starts and ends at the same place, and that's what you want. All right, so let's go ahead and get our values labeled. So we've got pi over 4, and then I'm going to go ahead and reduce that and make it pi over 2, 3 pi over 4, and then pi, and then 5 pi over 4. I'm sorry I didn't give you enough room here. You might have to extend this a little bit. 6 pi over 4, which you can reduce that if you want. 7 pi over 4. Honestly, I don't care if you reduce these. You can leave it 8 pi over 4. It doesn't matter to me. Same number. So it's up to you. If you want to reduce these or just leave them, that's fine too. So, all right, we're going to start out down here at -3, and then we're back to 0, +3, 0. Here we go. All right. Cosine always has these little hooks on the end because it would keep going on the other side. So I'm going to kind of hook it off at the end here. And it's going to loop up and then come down. So that would be one cycle right there. We're going to keep going. And there you go. So there's 2 cycles from 0 to 8 pi. Or I'm sorry, 0 to 2 pi. All right, I think I don't want this video to get too lengthy. I'm going to stop there, and I'm going to do a second video for the next part. So just hang tight. We'll do the phase shift in the second video. So take a break, and then come back and watch the second video with me.